welcome back to Kodamigo. In today's video, we're going to learn how can we perform insert operation on singly linked list. Now let's understand how can we add or insert a node into a linked list. So here we are considering the case first, and we are assuming that the head is pointing to null, which indicates that there is no node in the list. The next thing we do, we create a new node which has its next pointer set to null. So since this is going to be the very first node of the list, our next job is to set head to the node itself, and now we have a very simple linked list with just one node. Now let's also consider the case 2. In case 2, there could be a number of nodes already available. In order to be able to insert a new node, we have got to traverse the node all the way up to the last node. For this, we're going to create an auxiliary reference variable called node, and this node is going to refer a point to the very first node of the list. And then we use a while loop to traverse the list node by node. So now you see that node is now referring to the last node of the list. There's no more node to go to, and now we can create a new node just like before. The last thing that we need to do, we need to set node.next to these newly node created. Now let's implement the same thing. In our previous video, we learned about what a linked list is, what are its various types, and why one should prefer using linked list over arrays. If you haven't watched that video, please go ahead and watch that video. I have given the link in the description box below. So first of all, I'm going to define a node, because a linked list is nothing but a chain of nodes connected together, right? So let's define a class and let's call this node. In this class, there's going to be a constructor. This constructor going to accept two parameters. First going to be the data part, and there's going to be of type number. And second one going to be a pointer or a reference that going to point to the next link. So this pointer going to help us forming a chain of node, and we call that linked list. So this constructor has two parameters. The next pointer is null by default. That means while instantiating or while creating a new node, all we need is we need to pass the data part, and we can leave out the next pointer that going to be null. You see we have one error saying that duplicate identifies node. So let me do one thing. Let me wrap all this thing inside a curly braces. This is going to create a local scope, and now everything that we are creating should be accessible within this. First of all, let me define a class called linked list. This class is going to have a private property called head, which is of type node, and its default value or initial value is null, meaning the head could be a pointer to node or it could be null. So this is a union type that we have just defined in Typescript. Next is the definition of append method, and this append method going to accept only one parameter, that going to be the item that we want to insert or append in the linked list. And I'm saying that this append method is returning a reference to linked list. So you will see this. Next, so we know that by default the linked list is empty. It's saying that head is null, which means that the linked list is empty. If linked list is empty, then this head of the linked list going to be null. This basically is the first case. It does not require traversing the whole linked list. What we can do is that we're going to create a new node. We are passing in the item, which is of type integer. So this is going to return a new node, which is going to have two things: the data part and a pointer to next node. And here what are we doing is that we are pointing head to this newly created node, meaning by now there's just one node in our list. And finally I'm returning this. So this is a instance of linked list. And what would happen if there are certain number of elements or nodes already available in the linked list? In this case, we will have to traverse through all the elements. Then we would be able to append or insert a new node at the end of the list. So for this, we're going to have a node reference variable that is pointing to the head. So now there are two reference variables, node and head. Node and head both are pointing to the first node of the list. The next is a while loop, and this while loop is going to repeat line number 19 as long as node.next exists. So this is going to stop only if there is no more node to traverse. So what are we doing here is now we again are going to create a new node, which is going to have two parts, and node.next going to be the new node. We have appended one more node in the linked list, and finally we are returning this so that the append function, the Typescript, is not yelling at us. So this is the complete definition of append. So let's go one step further. Let me quickly define two more simple methods before running the program. So here I have quickly pasted a build method. This build method is accepting one parameter, which happens to be array of numbers, and returning a linked list. And now we are iterating over them and appending in the list one by one. So meaning that instead of appending just one element, we can pass in the whole array, and then internally this build method will use append method. So technically we can append or add more than one element in the array. The last method that I have created is a very simple print method. What it does is simply loops over the whole linked list, and it creates a string of the node.data, then it console that out for us. So I can now go ahead and create an instance of the list. Then I can use append method. So I can use append method. That means now there is only one element or one node in the list. Now what I'm doing is that I'm a bunch of elements and I'm passing all these elements in this array. So internally this build method is going to use .append method, and what I'm doing is that I'm appending two more methods, and I'm also using chaining, right? So remember that the append method is returning this. So this is a trick in JavaScript to make this syntax possible. So we can chain them. And last, I'm going to, now I'm calling one more build method. And finally, I'm going ahead and printing all the elements in the list. Let me click on this run button. Voila. You see that we have all the elements of the list created. So let me do one thing. Let me remove some of the elements from this, since build method also accepts chaining. So I actually can chain all of these operations like this. Now there's no need to use this reference variable or instance variable. I even can have int. I can put them in two lines. I can break the lines. And now I'm going to print the list again. So now our list is shorter and we have implemented an append method. Alright, so thank you so much for watching this. If you like this video, please hit the like button. If you are new to our channel, please subscribe to our channel, and I'll see you in my next video.